Uh, let's get started. So let's talk about what we're going to do today. Today we will be the first half. We'll quickly finish the regression because there are no new thing to learn. Basically, just apply what we have done, and we just tell you. Can you hear me? Is it the mic is? Can you hear? Yeah. So we tell you the regression, which is one of the most useful tool from this class. But you will see, because we are not asking you to memorize a theorem, what you learn will be looking at the Excel outcome and then tell you how to take action on those and how to interpret those things. And then break. Okay? And after the break, we will have you reply, you tell me. It's more like Q&A, and after that, if you have time, we'll go over the sample questions, the past year paper. And if we can't finish, we will go over the past paper in the Friday as well. Okay, so that would be the goal of today. Okay. So I think during the break, we will do CTE as well. Okay. So let us quickly finish the regression, which you would find yourself keep doing this if you are into the data industry. So just quickly, a quick class on the regression. So basically, you are looking at the case where each observation will have two measurements, and you would like to see these two measurements are related in certain way, right? The idea would be education income, right? Many of you would be considering taking the master program, right? You would be thinking about, okay, should I do the master and spend more time and money in the school, right? Is it worth it? So the question would be look at how additional degree can lead to higher income, right? So you want to look at the historical data and see if that makes sense, right? Next question would be if you are working for the marketing manager, right? You want to see if you spend more money on advertising, how much sales you're going to generate, right? Then you would see what would be the optimal level of advertising, right? Similarly, if you are working for medical study, you want to see if how much drug you want to give the patient to see how fast they recover. All right. So the question is no longer grouping, right? Remember, ANOVA is casting with the grouping would do, right? So essentially, you would group data into different grouping, right? And it's categorical group, right? So that's not much you can say. You can just say whether they're same or they're different. So there's not too much to be said there. But now we want to build up the relation, the quantitative one. So the main input you have is data, right? Each observation, you have two dimensions of observation instead of one, right? Say X1, Y1 will be, you pick up one person, you ask what is his education and what is his income. And same for the second lady you met, you ask her what is education and income, so on and so forth, until you get N people there, right? And you can summarize it in a scatter plot, which you learned in topic 1, right? You have scatter plot there. The question is try to find a line to best represent data, right? So the idea is you try to condense the information from the data to a line, to a straight line in particular. And some of you would ask, why a straight line, no curve? Yeah, but we are in the introductory class, so we focus on a straight line. And how to draw curves, how to draw complicated stuff will be something you will learn if you go further. So we focus on the line. But Excel, or if you study a bit further, everything would be no problem. So everything would be very similar to what we have found here. Okay. So from math, okay, you know, from high school math, you know, a line can be represented by y equal to oh, that is 3 years, sorry. The line would be equal to y equal to a plus bx, right? So so basically what you would see is the following, right? So you got, what you get is you have a bunch of data represented by the scatter plot, right? So basically what you get is this, right? You have x and y, right? You meet Mr. One, right? You ask his x and y, give a point here, and then you meet a lady number 2, right? X and y2 is here, so and so forth, right? And you try to fit the line here, right? And you learn that from the high school, if I write the line y equal to a plus bx, right? This, the y-intercept is a, right? Because you put x equal to 0, y is a, right? So the intercept is simply a. And the slope of this line is b, right? The slope, right? Because if you increase x by 1, y will be increased by b, right? So that's for the slope, right? So give me the y-intercept and slope, then I'm done, right? Because that is the line, what it means, right? No matter where you are, the steepness of the line is the same, right? Regardless of the location of x. So basically what you are doing is we are given a bunch of points here, right? Bunch of point, the data point here, right? And we try to move up and down by changing a's, rotating by changing b, such that I want to find the line that best represent the data. Okay. So remember, our goal is to have a line to represent data, right? Let's collapse the information along data point into two numbers, a and b. Okay. And what do you mean by best fit is the vertical distance. And all the vertical distance there, right? We try to move around the line, and this black distance, right? We change. What is the goal is to minimize square of this distance. By square, it means I don't care whether it's above or below. I don't distinguish. But when I square, means that if I'm so far away, I would be way worse because I square. So that is the meaning there, right? Same as the variance, right? The variance I took the square. Okay, so that is the idea. Okay, so by regression, I try to like this graph, right? I try to take a distance blue and red to the minimum, okay, and square one, and that the meaning is called least square method. And this method, you can see there's nothing related to statistics, right? So you would learn that if you learn linear algebra in the math department, not in the stat department or in computer science, where you don't really worry about probability, right? There's nothing about probability here. Okay? It's just mechanical. You give me y and x, this is the line that best fit. Okay, so that's why it happened before probability theory. It has 400 years old. Okay, in the and it's very useful, right? Just like trying to find the best fit, right? Just idea, right? It's a more like mathematical model than probability model, right? And before we go to probability, but let's look at we try to find the intercept and slope to minimize B. Okay, what are those A and B's are, right? Given that you are doing this mechanical exercise. Okay, of course, later I'll talk about how to do it in Excel. And it turns out the property is rather desirable. The thing is, the line would pass through X bar, Y bar. X bar is the average of X, right? You forget about the Y, carry average of X. You forget about X, carry average of Y, right? The X bar, Y bar. It's a point which may or may not in your data, but this is the average X and Y, right? Basically, if X is education, that is the average X education of the data, and Y will be the average income of data. So the regression line will pass through the center of data. The second one is a slope. How steep is the slope? The steep of slope is given by fraction. It's covariance over variance, okay? Which you would see is a little bit tricky, okay? But the numerator, some things should not be surprising to you, because covariance is capturing how strong they're related, right? And if the B is positive, right, it's positive slope, right? And variance is positive, right? So the sign of B determined by covariance of Y and X, right? So that means that if they are positively related, the line you draw will be a positive slope, right? If negative, with a negative slope. So that is pretty much normal. The only difference is you may wonder is why I have variance of X in the denominator. The idea is easy to understand if you try to look at this particular graph here. Say, how do you affect the data? Okay, and you can see that the data shows a blue line and a red line. Okay, and both of two possible scenarios have the same mean Y, right? And X bar also the same, right? Variance of Y the same anyway, right? And you can pretty much show the covariance would also be a little bit the same. So, but the thing is, look at this blue and the red one, okay? And you can see that the variance of X, okay, is higher than variance of Y, right? X is more spread out than the Y, right? Because X, the center is X bar, right? The blue one is like more spread out than the red one, right? So the slope of the blue one would be lower than the Y, right? So that's why the variance of actually increased, right? So that is some idea goes on here, okay? So of course, because now the formula is given by here, okay? You can always calculate that, right? If I know the covariance and variance, I can calculate B, right? And I know the mean of Y and X, I know A, right? So that's pretty much very straightforward to calculate, okay? Of course, in the example here, I told you that how you can do it. If I give data, how you can operationalize this, right? That is what I asked you to the homework 5, which you don't need to submit, but you can take a look. This is what I'm asking, the homework 5. But I want to show you how to do Excel, because that is super simple to do that. So suppose I have data Y and X here, okay? And suppose I have some data here. I don't know what are they, but okay. And I have two set of number, which is X and Y, okay? And what I want is I want to have the least square estimate, right? I want the slope and intercept, okay? So how I would actually do it in Excel, very simple. I want to have intercept, okay, and a slope. Okay. Excel would actually tell us the following, which is for the simple, the intercept, just type intercept, which is A. You tell them what's the Y there, what's the X there. That's it. Okay. You ask the intercept, give the intercept. So like this. If I ask the slope, they give me the slope. Okay. So I'm done, right? So that is what Excel tells us quickly, right? And probably you ask, okay, I calculate slope and intercept. What does that mean? It means a very profound idea, right? It's a mathematical model, right? You have a bunch of data here. That's some of data. Now, you basically condense this data into a following equation. What you said is y is equal to 2.x3 plus 0.41x. Okay, you condense this into a simple equation where if I give you x, you can tell me what you think about y. If I give you y, you can tell me what you think about x, right? So basically, it's you basically simplify everything into a very simple equation, right? And the collapse of data into something so simple is the idea of mathematical model, right? Actually, you also learned that in probability model. You learn in topic 3, right? You collect data of how people arrive. You assume they're Poisson. You collapse it in the lambda, one number there, right? That's probability model, right? If you think the future is arrival of the income of the person's normal bell curve, you're already there, right? But this is not a probability model, but a mathematical model, right? How X and Y related. Okay. So statistics is basically collapsing data, right, into something much easier to handle. Right? That makes our life easier. Right? That actually what happened when you look at the recently very hot topic about ChatGPT AI. What actually doing, right? Why the ChatGPT are so smart, right? What they're doing is actually AI. What is the input? You have 4,000-year history of human knowledge. They feed the data there, right? No one can read all those things, but anyway, they feed into the machine. And the machine, what they do, right? Of course, every time you run the machine, click it, it just come back in within a second. How it can be so fast? If they have the computer have to go back to check the thing, right? Is they simplify it, right, into a billions of parameter, right? Like here in this model, you have 2 numbers, right? But what the ChatGPT or the AI doing, right? The billions of trillions of parameter learned from the data, right? Collapsed it into a very simple equation, right? And that makes it work, right? And that actually how we do things in the real life. What you learn in this class or other classes like this, right? You have so many equations, so many knowledge to learn, but you grab the main knowledge of them, right? You grab the idea what the regression is doing, right? Fit line, right? You know, hypothesis testing. What you're doing, right, is if the mean is too far away from the X now, right, then you would try to say the X1 is more likely, right? Same idea. You remember the main idea. Of course, you don't record the detail, but you have the main idea in your head, right? Same idea here, right? You collapse everything into much more simple form. Okay, that's a regression. Is that clear what we're doing here? Okay, and there's no problem. So what we left is try to see include probability here, okay, and try to say this number actually makes sense, Okay. Under what condition this number actually would be a meaningful or usable thing, right? Because what we're doing is to collapse the data into information, right? But this line, right, doesn't seem to explain this, right? Because unless all the data is on the line, the model, right, does not actually represent data, but cannot use that to generate data, right? How can we go to the other way around, right? Is there any way that, okay, if I have this model, can I lead to this one? Okay, how can I go back, right? That is actually based on what we call the probability model. Okay, we will actually talk about soon. But so far, the least square estimate is the mathematical model. Well, you learned that from your linear algebra, right? Class, okay, or even your primary school, kindergarten, right? Try to find the line only, right? So now let us go back quickly to the model. Okay, so here is the model to say how we can go from the math model to probability model to justify why, although the models align, sometimes we observe something above the point and below the point. To do so, we need to introduce one thing. That's very simple. Actually, we see this is the thing that differentiates the least square model to a probability model, right? So that's why if you learn math 1 or math 2 in high school in Hong Kong, you don't learn regression because you need to talk about this epsilon I before you do it. Okay, or that's why same as ANOVA, right? That's why you don't learn in the high school. You left in the college because you need to understand what it means, right? It's basically epsilon thing, right? Remember, ANOVA, the model is like this. If you still recall, instead of this, it's alpha I plus epsilon, right? Different group have different mean, okay? And this group will lead to different alpha I. But now, ANOVA, we want to use X instead of different groups, right? Different groups will give you different alpha I. But now we no longer have a discrete grouping. We have a continuous X. So that's why it will be this linear relationship. Okay? And this is our model, right? We are thinking that underlying, okay, we believe that Y is our Y is the income, education. It means that if I spend one more year in school, I'll have better, more income. Okay, that is our belief. Okay, on average. Okay, it's a linear. Okay, and which may or may not be true, but we're trying to say why this least square will make sense. Okay, and the last one is called error. You can imagine that that is what we call the unobserved thing in the model. We didn't model it, right? We say more education can lead to higher income, right? But then many things would change your income, right? Maybe whether you are healthy or you're sick, whether you are handsome or not so handsome, you are so beautiful or not so beautiful, right? Or many other things that is a random in your life, right? That affect, right? Whether you got a good job, luckily, or not, right? You got a nice internship or not, so on and so forth, right? Or you really got an A from this class or not. Many things, right? Or you met your interviewer, is an alumni of CHK, this school, so you got a job, right? There are many events that affect or luck, right? Or you got a stomach pain when you got the interview, right? So you do poorly, right? For the important interview. Many reasons. Okay. And another assumption that would generate nice thing is X, okay, are not random. Same as whether you enter which group you're in, the gender, the thing is not controlled by you. Okay. And this last thing, right? The thing that is outside the model have mean 0 and constant variance. Okay. This mean zero has doesn't have a particular bite here, but we're just saying that on average this model is correct. Okay, and this luck thing is the same across everyone. Okay, and this thing can be dispensed easily, but we just keep that there. Okay, and the last one saying that random stuff are not related. Okay, and for those QFN students, this is something you will drop when you look at stock market data. Why? Because when you look at stock market data, suppose daily data or minute by minute data, you expect what happened in the past would have impact on today's stock price, right? If yesterday is going to go up, today's more like go up than go down, right? That's what we call positive serial correlation, or simply serial correlation. And that you will drop when you talk about financial time series. Okay. And that's basically when you look at time series data, that's something you drop. Okay. And of course, if you want to learn further, you will need to study time series, right? Especially go to the SEC department, you can learn time series model. Okay. And number 3, you will drop. Okay. When you study 2021, you remove this assumption. And for number 2, if you want to drop, it will be the graduate school. Okay. And if you want to drop one as well, you can drop some of them in the 2021 also. So all these are very restrictive, but probably you ask what you learn from 2021, right? Or more advanced class is basically learning the regression, but basically making everything more general, suitable for many other situations. And you learn machine learning, AI, or all those things actually is all those are regression, more or less. Okay? Or they more generalized version of regression. So if you want to look at data as a career, basically you're fighting this in various forms. Okay, different form, different format, or all those. So if you want to take it for your life, then that's it. Okay, and just a very quick talk, right? Those of you who learn, right, AI, right? They talk about the neural network, right? And basically it's like this, right? You have a bunch of data here, right? There's a bunch of input here, and bunch of output here, right? And output here, right? And you learn those. It's like the neuron is like in the middle, right? And you're here, right? And what actually they do is simply running regression here, and they run regression here, and run many layers of regression. Okay, and get here regression. Okay, and you get regression here. Okay, output. So basically, just keep running billions of regression, you get the result. So regression is like fundamental to many of the way we do. And actually, in your brain, in the nature, somehow the DNA chromosome is more likely they run a regression as well, right? So that's why we have a lot of illusion, right? You look at things under the water, right? Actually running a linear regression down there. That's why things look more shallow, right? They look at down there, right? Those who swim will know, right? And a lot of things that are, it's like in our head, it's running a regression, but that's way beyond what we want to cover, okay? But we're just trying to say, under this kind of assumption, which we'll call the classical assumption regression, probably at this moment, you would produce this like the foreign language, right? But don't worry, because if you will never appreciate that unless you drop some assumption. When you have learned a new model, then you learn why they're important. I just put it here. In case when you learn the future, new model, you come back and see. Okay? For you now, it's basically more or less nonsense to you. Okay? You only appreciate what they mean, what the meaning of them, exactly meaning of them, until it's a difference. Right? So only when you compare, you appreciate what do they mean. If you don't do the math, right? So what I want to say is, if you want to make that a property model, what it means is the least square estimate A and B, which we have said, or which we found in Excel, is actually that the unbiased estimate of alpha and beta. Okay, if the true thing is actually come from alpha and beta, you lose least square estimate. They're the best. Okay, it means that if you get a data, you run the regression one time, you have another data, you do regression another time, you have many regression. Average of this intercept and slope is actually what you want to find. Okay, so that means that if you have some study in Hong Kong about X and Y, go to US and do it, go to China and do it, go to everywhere and do it, average and all, we discover the truth. Okay, and that is actually what happened in science, right? You do some discovery and go to other lab and do it and keep doing, right? Or medical science, the same, right? And run the regression, we are able to discover the truth, right? And another good thing is what we call the efficient estimator. Okay, if we call efficiency, means they're accurate. So, and it's good, right? It's accurate and has low error, right? So that is why we learn this, okay? So this equation, this formula, this solution is actually good, okay? Not only it's a nice mathematical structure, minimize least square, okay? And even if you consider that as an estimator, you're not going to minimize the least square, right? What we're going to do is, I want to actually guess that guy, right? If the data generated by this, okay? I don't want to minimize least square, okay? I just want to guess the slope and intercept in a nice way, right? If I repeat this many times, getting different A and B each time, right? And average of those is actually I have alpha and beta. So that is the nice idea, right? Turn out that surprisingly they're coincide, right? So that's why it's very good. Okay. Is there any questions? Now, the very last thing we didn't cover for this model is the sigma square, right? In this model, there's only three things we don't know. We need to know is the intercept, the slope. Last thing is this guy. This is a new thing when you introduce a property model, right? Because the model only sigma square is with the probability, right? Alpha and beta is simply just a number. You don't know, you want to guess it, right? But the sigma square is governing what we don't know, right? It's a random factor, sigma square, right? And we want to have a good guess on sigma square as well. Okay. And to guess that is not difficult because this is variance, right? And we learn how to estimate variance, basically sample variance, right? But how can we estimate sample variance in this particular model? Okay, turn out to be, okay, it's a very complicated formula, but luckily, okay, it's very simple. Okay, turn out to be, you just get the data, you minus or estimate, give you the residual, you calculate the sample variance of the residual, is our guess on sigma square. Okay. Now, probably you would not see what I'm talking about because so much complicated math. Okay, let me draw a graph, then you understand. That's very simple. Data X and Y, right? We are claiming that the underlying relationship between X and Y are governed by okay. This is what we believe this world to be. Okay, our income is governed by some alpha plus beta X, right? Our education plus some random thing, right? And that random thing that leads us to different observations. So you expect, right? You try to get data. You may see in here, right? Right. This is the data that you may observe, and it's the epsilon thing that drives away from the line, right? With the epsilon, everything will go on the line. Okay. And what data you observe depend on what epsilon realize, right? And the line actually can draw, suppose it's the data you got, right? And you may actually end up in this line, right? This is a line that you actually draw from your data, right? And of course, there are many lines you can draw, right? But on average, you collect all the intercept. On average, it's same as the alpha you got, right? You may got this line, okay? It depends on data. You may got another line, okay? There are many possible things, okay? But suppose I focus on one line only, okay? What is my residual? Residual is, remember, I never know the real line, so the red is never known to us, okay? We just believe there's something in the background, but we can calculate this, right? Once I draw a line, right? This is x1, y1 is my data, okay? And the line is given by head equal to a plus bx, right? Okay. And this point is y1 head, right? So we call this is called the residual E1. E1 is given by y1 minus y1 head, right? So it just y1 is our data. Y1 head is a plus b x1, right? So this is called the residual, okay? And this, you can calculate variance, sample variance, right? They're all, each data point, you have one residual. You can calculate variance of the residual, okay? And that would give us the estimate of sigma square, right? Because this is our variance. And we use this, come up with the sample variance to estimate the sigma square. Okay. And probably ask why we care about the sigma square, because it tells us how good the regression is, right? The larger the sigma square, the variance is not as good as the other one, right? So, and usually we care about the standard deviation called standard error estimate to the square root. Okay. So basically take the square root of that. And some of you ask me why I have n minus 2 here. Okay. And that is very simple. Remember why we minus 1? Because we estimate sample mean. Now we have two sample mean, x bar, y bar. So minus 2. Okay. And of course, if you want to prove it, you'll be 1A4 page of proof. To prove this is unbiased estimator. But I'm not going to put in the slides, but actually can prove, right? So actually can prove this guy. Okay. That will be the y with M-2, but I don't want to go to that as well. Okay. Of course, you will say calculation this will be somewhat too crazy, right? So I want to tell you how you can do it from Excel, which is super simple. How to find the standard error estimate in Excel? Just standard error regression. Will be just STEXY, bunch of Y, and bunch of X.
Yes.
So that would be Okay. So probably you would ask, okay, I have a point estimate of everything of the model. That's good. Okay. So I know everything about the model, right? We have A and B. So next is probably, we're almost done, right? So what is left is you learn from the class before, right? We want to, with the point estimate now here, what we want is we also want to have two things. We want to have interval estimate, 95% estimate for the slope and intercept. The first thing, right? Interval estimator. The second would be, I want to test if the intercept and the slope are 0 or not, right? Are they useful or not? Right? That would be the goal, okay? I will show you the Excel function before I go to the formula, okay? Because I think the Excel would tell us everything there already, okay? So how do we do this Excel? Okay, you go to File, we will use add in, option to be add in there. Make sure that you have NS2 pack that is switching on. Okay, the data is here. Okay, and go to data analysis. Okay, which same as we do ANOVA. You just go to regression, data analysis regression. Okay, and then tell them the Y. Okay, highlight the Y, highlight the X. Regression, highlight the Y-X, and because of data label, you just tell them label. That's 3 step. Okay, Y and X with label, and then we're done. Okay, that's 3 click. Okay, and of course I want to last one output where, because I want to make it nicer. I just output not in the new spreadsheet, but output into here. Output. I tell them I want to output here. D7, say. Okay. So that's my result. So you can see the main thing to observe here is very similar to ANOVA. We look at the coefficient, which already given to you, right? It's A and B. Okay. And the next 3 columns, which are highlighted yellow, would be related to what we call hypothesis testing, same as ANOVA, right? The goal is you usually don't worry about the column F and H. You worry about column I. Okay. Column I will tell you for column H, right? You column H, look at this. The p-value actually is too large, right? Although we say that it's non-zero here, but this p-value is too large to say they're useful. What's the p-value doing here? The p-value of this, later I will elaborate a little bit more, but this is asking, I'm testing hypothesis where A or alpha equal to 0. It's a two-tail test, alpha not equal to 0. And this bottom one, I'm testing beta equal to 0 and beta not equal to 0, right? So we only use this regression when the p-value is less than 5%, same as ANOVA, right? So let me repeat what we're doing here, right? What we're doing here is telling you that, okay, we come all the way to the data. This is our model, right? Seems everything very nice, right? But do remember that we want to actually see if this coefficient are come out of luck, right? Because you collect data, you can end up having a nice regression just because of your luck, right? You want to make sure that this regression does not come on luck. Okay, You need to, as a minimum requirement, you whenever want the regression, you want to saying that increase in x, okay, is leading to a good outcome, has to be saying that this, the p-value has to be less than 5%, right? Of course, the smaller the better, right? But at least 5% will be the benchmark. Okay, this is the hypothesis testing. Okay. The next one I want to talk other data break. Okay. Another one I want to talk about is these two green column. These two green column would be talking about the confidence interval estimate, right? So will be 2.38 plus minus something give you this result. Okay? The formula is given in the slide. Okay, I don't think you would care about the formula anyway because no one actually do the calculation. Okay, but it did tell us that okay, this 2.83 can be as low as negative, can be as bad as 6. Okay, so it simply means actually this includes 0. That's why you can't use it. Similar here. Since this one includes 0, you can't safely reject that. Right? So basically this regression is useless. Usually that's all what we conclude. Okay. And we talk about after the break. Some of you ask, okay, there's ANOVA here. Okay. And you can see this 2.3 something is same as this number here. Okay. And turn out that I don't talk about this in this class, but when I have only single variable, the ANOVA result, F test, will be same as the T test of this guy, the same. Okay. And probably ask, is it the same? Why we do ANOVA? What's the point of doing that? Okay. If you have single variable X, F test and the T test the same. Okay, but when you learn the next course, if you ever go to other course, you learn if Y equal to alpha plus beta x1, beta to x2, so on and so forth. Okay, you have an ANOVA there, and the ANOVA will asking, are these beta 1, beta 2 are jointly 0? Okay, and in those cases where you run the regression, which you will learn if you ever do it, you will look at the F test first before you go to T test. Okay? F test is asking whether the whole model is useful. And after that, you want to see if individual are useful or not. But that's out of the scope of our class. Okay. And sorry, I have just borrow 1 minute. The very last thing is we'll cover after the break a little bit quickly is this very last thing is called R square. Okay, R square here is 0.42. Okay, which simply mean I'll elaborate later. It's very simple. It's actually saying that this regression explains 42% of regression. Okay, maybe I just give you the result because just need 1 minute to explain this R square 40%. Very simple. That's one. That's one. Okay. And look at this diagram, right? The scatter plot here. The green are our data. I draw our line is y hat, right? Our y hat is summarize the data. And the question we want to do is we want to use X to tell us how old the Y is, right? And remember, if I don't use X, I forget about X. What is your prediction for Y? You give me any random Y. It's Y bar, right? You ask me, okay, what you predict about the one's income? If I don't give me education, I just use the average in the population, the Y bar. Y bar is the model without X. Okay, and what you want the regression to do is to explain this distance, which gives us the HFC, right? You square that, sum of that. It's a thing that we want to explain. Okay, That is something want to explain. We want to do, okay? But what we actually do in the data is this purple one, SSR. What we have done, right? That's why you got R square is SSR over SST, which is always from 0 to 1. Okay. If this is 1, I should be more. If this is 1, it's exactly on the line. If 0 means it randomly along the X bar, Y bar, right? So this is the percent R square. It's the percentage of the variation of Y explained by the variation of X. So that's the exact definition of R square. Okay. And very last point. Sorry for very last one. Sorry for keep delaying the bit, but this is the very last one. So probably you would see, you learn from what we learned in the last class. Sorry, from the very beginning, we learned correlation coefficient X and Y, right? Which is the variance over the covariance XY over square root of X over square root of Y, right? Let's write that down. Covariance XY over square root of variance of X, square root variance of Y, or this guy, R square. This is small r square, small r, this big R. Probably ask how they're related. Turn out it's very simple. You square this guy, it's actually the same. The small r square is just big R square. Okay, this only hold when you have single variable. When more than one, very different. Okay, but everything's very nice when you have only one variable. Okay, and that's basically pretty much I want to say, because other slide I basically give the foundation for Excel spreadsheet. Okay, so I hope now just because we end our course now, right? So that's why I want you to go back to here to tell you again, R square, right? The E11 is the percentage of the Y explained by X. Okay, the higher the R square, the better, of course, right? Because that's how the fit the model is. And for linear regression, you want to look at the coefficient, you calculate, but before you're very happy, you look at the p-value. If the p-value is less than 5%, then you use it. Otherwise, you need to collect more data to do things before you trust the model. Okay, and that would be pretty much what I want to say. Okay, so this pretty much end our class, and with a break, I guess someone will do CT as well. But before we do that, I put the U reply first, and then that's a break of say like 10 to 30 minutes. Then someone come to do the CT, and then we will do the Q&A. So we do that. You reply, tell me your question, Q&A, and then we will do it. Let me open the U reply. Let's have a break until yeah, I think you will do reply, and then someone will come to do CT. So remember to leave your question Q&A, because I will try to answer them first before I go to the sample paper. Okay, so just ask whatever question you want to ask before we go to, because we pretty much finished what we want to cover already, the whole syllabus. So so we will go to Q&A, and then if I have time, we go to sample paper. And for Friday, the morning, we will also do sample paper if we haven't finished, and then do the Q&A. Okay, so you can decide whether The Friday is optional class, right? So you may or may not need to come.
Block. Yeah, it's blocked.
Oh, so like the other section, please write down your question if you don't want to ask me explicitly. Okay, write down your question and then see, and then we can do it. So again, I go around to see the question. T 冇㗎，Excel 會㗎。如果我咁樣問，如果我問你 P 嘅兩份，如果我真係問 P 嘅兩份，就咁有個有個 output 嘅。T 冇辦法做 P 嘅。如果問你 P 嘅你 T 我就要啦。如果係 Z table， 如果係 Z test 係。如果 T 嘅話就係但你個 critical error， 如果就咁我要做多決定到。考慮咗上考 ANOVA 定係考 Excel？ 都 same as 呢個 two sample test 都係。
因為突然間見到你人交佢本身就攞個 sample 面係48俾應該食大但係佢大部就先會住係
都係咪睇下佢
陳文如果大個就會做人，我哋都要睇下 reject 等於50之後，如果 reject 咗咪大過50，做緊大做直接相值嘅作用有人啦，
都要計翻 P 嘅，
所以係大
個 action，
唔翻上就 break，
就寫翻俾佢睇。你做大個 testing 係 before 要睇 data，you decide the before the data。係普通。
知係咪咁係咪啊？
呢個一點六四唔算係個，即係如果佢大，即係如果 set 大嘅，佢而家有個時間，一定偏翻呢個係啲
即係你由1歲到6歲啦，即係你知呢個 FX 係啲大嘅，即係你係大嘅比型，但係你呢個數咗翻大嘅，即係你攞咗個 Y 嘅 value 唔係 probability， 因為佢一點係零嚟㗎，一點係零嚟㗎，佢個 probability， 佢只係 return 個 function 嘅。有佢 Y 嘅，但我睇人一點個 probability 係零，咁所以我嗰陣佢就 return 個 Y 嘅 value，Y 嘅 X 佢係大概。
So let's see you reply to see if you have any question and we answer it, and if no, then we go to the past paper. First question, is it so the question is basically asking the announcement. So it's asking the scope of the test. Oh, right. If I said you have to know how to do all the calculation by hand up to hypothesis testing, one sample, right? I expect you to do it by hand. Of course, if something cannot be calculated by hand, then you can give me the Excel, but it should be explicit, right? And for the two sample and the ANOVA, I focus on one way ANOVA, right? I focus on Excel. And people ask ANOVA Excel function. No, ANOVA is I need you to know the Excel output. Okay. The question is like the past paper that I try to ask. It's similar to what I expect you to know. Later we'll talk about that, but it's a last year paper, right? It's like the ANOVA, like this. I expect you to know how to derive this table, right? If I take away things, then you know the interconnection between them, right? Just very briefly to go over that again. Okay. This is a table that we care, right? ANOVA, because at the end of the day, right? You run the Excel, right? This is the table you get, right? You need to know how to use it, right? Because our class is focused on usage, right? You know the theory, the theorem, the idea, then you know how to use it, right? And at the end of the day, the first thing you to look at, right? It's this value, right? This C value will be the thing that we care the most, right? Because what we're doing in this ANOVA is asking whether the group will be different, right? The group data by group 1, group 2, and group 3. We want to see whether this 3 different group will be different, maybe different business strategies, so on and so forth, different thing you want to conclude. And in this model, if you use 5%, then you can't reject. So you can treat the 3 groups the same, use the same marketing strategy, same treatment to the all 3. So that will be the first thing you need to know from this direct to the p-value. Okay. The next would be you probably would want to know how to calculate all these things right? Based on the formula, right? It's how you calculate between group variation, within, and total. Of course, I'm not expect to ask you how to calculate that, but you understand what's between group, right? Between group means you replace all the observation by the group mean and calculate the total variation. Within group is you take each observation minus the group mean and square and sum of them, right? And total is just same as the way you calculate the variance of the all data, but focus on the numerator part, right? And but what I really want you to know is, you know, these two add to this side, right? This is SST is SSW plus SSB, right? So if I take away any number, you should know how to calculate the rest, right? So that would be something that you would know, right? And the next is this degree of freedom, right? How do you get this guy? This guy is just C minus 1, right? If you recall, because it's a variation between group, it's number of group minus 1. How many group you have? 3. 3 minus 1, 2, right? And the next thing you know is this 9 is what? N minus C, right? What's N here? N is 12, right? Total number of options 12. 12 minus 3, 9. Okay. And this last one, you recall, this is N minus 1, right? And it's 12 minus 1 is 11, right? And you do note that 9 plus 2 is 11, right? So if I try to plot one thing out, you know how to calculate. But anyway, the next one is this MS B, right? MSB is just this over this, right? 1202 is 24 and so on and so forth, right? This over this gives you this. Okay. And you should take this over this guy, gives you this F. Right? And lastly, probably someone would ask how to calculate p-value and this guy. Right? P-value is nothing, right? But that's the area on the right-hand side, right? If you put in Excel, we just have this 2.3478 and put in 2 and 9, which come from here, right? And 2. 1 minus, because the area on the right-hand side is the right tail text, right? F is the left-hand tail, right? And if you want to calculate critical value, which is also the same, right? It goes F inverse for 95, 2 and 9. Right? That's how you know how the everything is there. Yes. Oh, I use the G notation, right? Oh, sorry. I guess some of you asked because I think I use the G notation, so yeah. Any further questions? This is how you know because this is the only table actually you do action on, so that's why I focus on this table. Of course, you should be able to come up with, you know what the meaning of this SS, right? How you get this guy. Because at the end of the day, you just compare variance, right? So that would be the okay. Any question? Good. No, I just erase this screen. Homework 4. You have to ask TA. I'm not answering any question on the homework. Because of fairness. but the homework answer will be released tomorrow noon after the deadline is over. I think the deadline is at tomorrow noon, and then we'll release the answer at 2 p.m. Okay. Just give you one hour buffer if you late a little bit, but after 2 p.m. we are not going to accept any homework submission. Okay, if you're late, then you're late. Okay? But the answer will be there. If you still have a question, you can ask on Friday, because that time you can have Q&A on. 2 sample tests is on Excel, so you have to know how to calculate Excel. I'm not asking you by hand, so I give you 2 samples. You can. I would just ask you to give me the result, right? Possibly, but I'm not expecting you to do all the calculation. Okay, the complicated formula. I think you're asking what formula, right? Because that is the formula, right? The t-test. And also the f-dot test. Right? I mean, if you look at that, that would be the true thing that you will be looking at. Will exam cover the question type? Well, that is a very complicated question. So I guess the question is, I always ask 95% in the past paper, but sometimes I do 90%. Like, no, you ask, it's nothing, some variation, but to be put in this way, I would say our exam and assignment will be very similar, right? You agree, right? And actually, the assignment is more difficult than the exam. Then you should be thinking about exam will be the past year exam will be something a good predictor, will be unbiased estimate of what you see. So it's not more. I mean, it's similar level. So if you're able to understand the assignment, it's a zero problem of doing exam. Okay, or you have you know the past paper well, you understand what's going on, that's fine. Of course, it will not be exactly the same question, but same style of question, same focus here and there, but some variation to make sure that I know you know, right? So, yeah, you can bring as many cheat sheets as you want, but you can't share with your friend. Okay, and second, please bring your calculator, right? Unless you are very good at doing division and subtraction or taking square root. Okay, I recommend you bring your calculator. Okay, if you don't blame me. Okay, it's your problem. Okay, bring your calculator, bring whatever set table and t table you need. And the t table and set table or f table that I put on the line will be sufficient. Okay. Unnamed attempt. Okay, I can. So the question is, someone want unlimited. Okay. Done. Too difficult. That is too weak answer. Too difficult is a material difficult, exam difficult, this class is difficult. I suppose you say this class is too difficult. Then at least you know one thing. You don't want to do data for your future. That might be a good idea. And I would say I can't say my class is easiest among all the sections, but I would say one of the easiest. So if you have struggled for my class, and probably you would have struggled for other sections as well. So good luck in your future. But hopefully you would do your project, do your assignment, and take your exam so that you still get an okay grade from that, even though it's difficult. But to be sure, this class by definition is slightly more difficult than other class because it's a quantitative class. So But I would say if you go to STAT, my class is a piece of cake, right? If you study the M1 or M2 in the high school, this class is not too much difficult from that. I mean, if you have the knowledge from M1 or M2, or if it's just M1, basically you get at least C from this class, even from that, right? We just doing some more ANOVA and Excel. So not too much difficult from that. I said you bring your own C and T, okay? You bring your own, okay? The one I gave already on the blackboard already should be sufficient. I'll double check with our PA, okay? In the worst case, I said, in the worst case, you forget to bring, you write down the Excel function, we'll still give you almost most of credit for that, in case you just fail to do it. I think I answered that as well, sufficient, okay? In the case I'm wrong, that I make the question that the table is not enough, then just leave the Excel, you get the full credit, okay? So you are protected by insurance issued by me. If the table is not enough, you write Excel, you get the full credit. Okay, so don't worry, you don't need to bring more than table I provide. I'll talk about today if I have time. Or we're sleepy, yes. Coffee is a thing that makes you less sleepy. So I recommend you have a coffee before you go to exam, if you're not super allergic to that, or tea or whatever. Or chewing gum or Red Bull. Red Bull will be too strong, but you can take the Red Bull. Not ready for final. So we cover past paper, hopefully make you feel happier. Project. Yeah, project most in the things like grade project, usually people would get B or above. Only one or two exceptions I give B minus, but mostly people get A minus or A. Some will get B plus. But I can see from what you do, right? If you don't spend effort on that, then clearly, I mean, getting a B will be, but B plus is very, the median grade will be B plus or above. Yeah. For the project, I mean. Not this, but of course the median grade, of course B plus for sure, right? For this class. But for the project, I don't know. But usually, right, in the historical distribution of having this class, the median grade, right? I think it's B plus. Yeah, B plus. Yeah, B plus is the median. And yeah, unless we screw up everything, then right, you would be low. But it really depends on how the effort and the thing, right? So. Oh. So maybe many people are just still sleepy. So just make sure today is Wednesday, not Tuesday or Friday. Exam? I can talk about exam. So I haven't talked about exam yet, but okay, you already learned the exam already. So. Oh. Crab? Okay. You think crab is good. I think now the crab is very cheap right now. So try more crab. You want to? So overall is fine. I think the speed. Just to remind you today, the regression is not included in the exam. But I cover it because if you want to include in your project, that would be good. Okay. Just to remind you that today, next week, we have a tutorial, optional tutorial in the B.A lab at night, optional. So you can either next Monday or next Tuesday, the same. So you can either, yeah. So if you don't, doesn't really matter because I just want to do program. Okay. And anything else? So let's see if they do it correctly. Okay, this is a good exercise. So the question is, today final, tomorrow final, the day after tomorrow final. I don't know how to do assignment. I don't know to do the final exam. Okay. To test GPA equal to 4 or not equal to 4. Fixed courses. The sample mean is 1.7. I think sample mean is GPA, right? The grade. F is 1.64. Okay. So this is correct one. Now I would say this might not be
standard deviation population.
the standard deviation. It's a sample population. The
Sample.
population, you do the exact is right. If it's sample, this is wrong. But I guess given that I think that it's a population, okay, it's a population, because no way this is then it means that this is 2 tail multiplied by 2, that's correct. Okay. And so the p-value is this. That means that reject this. So that's why it means that's not unlikely is 4.
Okay, healthy.
Right. So that's very good. Right? Good exercise. Is this correct, right? By the way, where will be the final? Okay, good question. So final is here. See YIALT5. Okay. If this Friday, just an hour. Okay. I'm not going to do any extension, just 1 hour is 1 hour. Okay. So I just like 15 minutes later to make sure that everyone is there on the spot. Okay. It's there. Bring your ID, bring your calculator, bring as many physical copy of your notes or keep it whatever you want. Remember, you can't share. Okay. Of course, you can photocopy from your friend, but you can't share with your friend. Okay? And if you can't attend for whatever reason, we will approve it if legitimate. Okay. If you don't have a right reason, if you miss it, then we'll consider you absent. Okay. Please email the TA. You get approval must if you have to excuse from the final. We'll schedule make up. Okay. But have to be pre-approved unless medical emergency, right? Or some other emergency that justifiable. Otherwise, no justifiable reason beforehand, consider as absent. The standard thing. Okay. And makeup only allowed next week, not before. Okay. After next week, we will schedule some makeup. Okay. Because there are some logistic things, right? Where put you the makeup and then with the TA to individually use many things. So we have to get a pre-approval and do all the stuff. We have lesson on Friday morning. It's optional. So I go over the exam paper and all the Q&A as well. You can attend by Zoom or you don't have to attend. The last one is not taking attendance. The last one. So if I ask you the Z test, right? Then you know how to do, right? You can know how to make judgment, right? So then, unless I explicitly allow you to Excel, right? Do Excel formula will deduct some mark, right? I ask you whether you reject or not. You tell me depend on Excel function, then probably not answering the right thing, right? But we still give you some credit for that. But you'll be very clear. If I ask Excel, you'll be very clear in Excel. Okay. F table, well, depend on your significance, right? But as I said, probably you don't worry about F table because I said two sample tests based on Excel, right? And ANOVA based on Excel. So you probably need not use F table. But if you check based on 5%, 10%, 1%, depends on what you think, right? Of course, the question, if I gave, will ask you 5%, then you decide. Why a number? Well, because last year the homework is I think by me. This year the homework is by TA, so TA decided this is more fun, so then she do it.
Yeah, I guess.
So you look at the part last year assignment is a little bit more moderate, but he think that I think he thinks it's more extreme than you know what's going on. Actually, in the real world, it's that extreme. Surprisingly, I think PA actually doing a good job is because in the real world it's extreme. Either you reject or not reject. Usually it's a very clear cut instead of something along borderline. But that's why I think PA is doing a good job in terms of what actually we see in the real world. It's either you just very big you reject, either you don't. Usually it's not very intermediate. Very rare you have intermediate case. Oh, that's a good one. If healthy job are welcome, and then you said unhealthy job parking so. For those who know, welcome is one of the supermarket chain store locally. Is it a joke or not? So we still have time. So not to waste your time, let's go over the first question. Okay. Just to remind you, our exam has 3 long questions. 1 question like this, ABC part, right? Or D or E, but that would be the question of like. So only have 3 questions. Okay. So all questions will be needed at 10, okay? No multiple choice. Okay. So the first question, you can see this one. I asked you Excel input, so you know I asked Excel, right? So if I don't ask, I don't say Excel, I expect you to write down the answer. So this one is I have John, who is salesperson in the company. His recent sales is this one. What would be the sample variance, right? So check your hand out. The answer is this, right? Yes. Okay. Is that okay? This is the solution to that. So here I ask sample, right? If I ask population, right? You know what to do, right? If I ask standard deviation, you know how to do, right? If I ask whatever thing, the topic 1, I just replace that, you know how to do it, right? I mean, you should be able to do that, right? Because that is a basic technique, right? I mean, you finish this class, don't know how to do this, right? That is a big problem. So what I'm asking in the final is very straightforward, that the thing that you actually need to use, right? I'm not asking very particular things, how to interpret variance or the formula to that. No, not really, right? I'm asking very applied questions. And actually, you actually will need it for your future work. Okay? Is that okay? Now the next question. I will left the part C next class because I don't have time. Part B, the day number accident followed Poisson with mean 90. What should be the Excel input to calculate more than 92? So here, actually it's pretty straightforward, but only one tricky thing here is more than. Okay, so let's write down this in the formula here. Okay,
so
the question said the following: number of accidents, right, is Poisson lambda equal to 90. Let's call X. Okay, now X is the random variable that equal number. So what is the question actually asking? The question is asking this: probably that X is more than 92. All right, so that is question asked. So we have to be very careful because it's a discrete number, whether it's more than or equal to or more than. Okay, if you make this mistake, then you have it, then you miss. Okay? So this one actually means this, right? Actually, you have to go X equal to 93, X equal to 94, and right? Go to infinity, right? Then, but our exam only 1 hour, so we cannot do infinity, right? So what do you do? The final one is going to be 1 minus right? So 1 minus probability x equal to 0 because it starts from 0, right? 1, da, 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 da. 92. Okay. But this guy, you know what's that, right? This is just Excel will be horizon 92, 90. And that means that the final answer is oh, sorry, I forgot the case, huh? My mistake. Stop. Yes. Huh? Is that okay? So we will talk the rest of the question and more Q&A in the Friday. It's Friday, I don't take attendance, so it's optional. You can come or you may not need to come. Okay, if you're busy in the library working or sleeping or taking rest or the other thing, you can feel free to do it. Okay, so thank you. There's not much thing I can say. Good luck on Friday. Okay, see you. Enjoy your crabs. Bye bye.